Alright, so we have derivatives of inverse functions. So, looking at this guy, we are going to start off with the basic rule. So, if there's a function f of x, and we say that g of x is equal to f inverse of x, then we know that if you have a function f of x, and you evaluate it, you end up with a y value. Well, that y value happens to be the x value of g. And so the x and y actually switch places. What happens is, if I know the derivative of f at x, then I can also find the derivative of g at that y value, specifically this y value, and that becomes 1 over f prime of x. So if I use points, so let's say I tell you that there's f of 2 is equal to 3, and I tell you that f prime of 2 is equal to negative 5. Then if I know that there's an inverse function, then I also know that g of 3 is equal to 2, because the x and y values switch. Then I also know that g prime of 3 is equal to 1 over f prime of 2, which happens to be 1 over negative 5. So they're just opposite, they're not opposite reciprocals like perpendiculars, they are just reciprocals of each other. So graphically, here's a graph. So here this blue is the f of x, and this here is g of x, so they're inverses of each other. That red line right there would be y equal to x, so they're reflected across that line. Here's a point, f of negative 5 is 2, and I'm telling you that the slope there is 3. So now I know if I find the other point, that's the inverse point, so the x and y are switched, but I know the derivative at this point, which is at 2, is the reciprocal of the derivative of its inverse point. So what I want you to see is that we're not finding the derivative at the same exact x value. We're finding the derivative of the inverse points. So here's a problem that you can try. Go ahead and press pause. Alright, so if I see this, it kind of tells me that I'm using that inverse rule, h prime of 0. So if I know that I'm trying to find h prime of 0, then that would be equal to 1 over f prime of x, where on the f function, the y value is 0. So this is actually fy value. And now that I know that, I can take the original function for x cubed minus 2x squared plus 6x minus 3, make that equal to 0, because that's the fy value. If it's the inverse's x value, then it's fy value. So I'm going to factor by grouping here. 2x cubed, no squared, I mean. Square would be the biggest I could take out, and I get 2x minus 1. If I do 2x minus 1 here, I would have to factor out a positive 3 equals 0. Common factor is 2x minus 1. Leftover terms are 2x squared plus 3. And so I get 2x minus 1 equals 0. I get 2x squared plus 3 equals 0. I get x equals positive 1/2. I get x squared equals negative 3/2. And this one can't be solved for real values, so this is the only value I can use. Therefore, I now know that if I can find f prime of 1/2, then I can find h prime of 0. So easy derivative to do, because it's just the power rule. F prime of x is equal to 12x squared minus 4x plus 6. So f prime of 1/2 would be 12 over 4 minus 4 over 2 plus 6. So I get 3 minus 2 plus 6, and I get 1, so 7. Therefore, h prime of 0 is equal to 1 over 7. That's the answer.